So Joe Chmielewski with Manta is the sales engineer, and he has more than a decade's worth of experience in the information technology space. He's been with Manta for the past year and has worked on projects ranging from pre-sales solution scoping and design to implementation and enterprise-wide deployments of the Manta data lineage platform. So Joe is going to be talking about powering the modern data enterprise, how data-driven teams use data lineage for strategic advantage. With that, Joe, I'm going to hand the mic over to you and have you start your keynote presentation for all of us.
Sounds good. Thank you so much. So hi, everyone. My name is Joe Chmielewski, and as you heard, I'm here to talk a little bit about some data lineage. So I'm going to go ahead and share my screen here. Just give me 1 second. Okay. So we should all be looking at my PowerPoint screen now. Please feel free, anyone, to interrupt me if you are unable to see my PowerPoint presentation. But let's just jump into things right away. So before we start getting down to the nitty-gritty details here, I wanted to talk a little bit about today's agenda. So what we're going to go over is I would like to do a brief introduction into the data lineage platform itself. For any of those of you who are not necessarily familiar with the data lineage industry, we're going to give you an introduction to that and kind of how this all works and how it all looks within your ecosystems. Then we're going to talk about some real life use cases. So accounts that we've come across over the course of our years here and how they've utilized the data lineage tool and data lineage approach to solve some of their different challenges that they've come across over the course of the years. Once we've gone through the different use cases, we'll leave the last few minutes open for discussion. We'll do a high-level Q&A session so I can answer anything that comes up during the presentation. So please feel free to post your questions in the chat, and if we have time at the very end, I'll go ahead and get to those as best as I can. So let's begin. Okay, so what is data lineage? Well, at a high level, data lineage can be thought of as a family tree for your data that traces the parent-child genealogy back to the beginning of time. But this family, like most, can be a bit dysfunctional. Not everything is as it seems on the surface level. As we peel back the many layers to the metaphorical lineage onion, we uncover connections between elements that we may not have expected, as well as identify assets as being highly important that otherwise would have gone unnoticed, or worse, could have been modified. But how does understanding how data flows within your organization help to improve your work as a business owner, analytics specialist, data architect, or casual lineage enthusiast? Well, in the words of Neil deGrasse Tyson, we can turn data lineage into information, information into knowledge, and knowledge into lineage wisdom. I may have tweaked that statement slightly, but the premise is still the same. How can we get to where we want to be with our reports, our root cause analysis procedures, impact analysis protocols, and system migration projects without knowing where our data has been and what it has gone through to get there? What does data lineage wisdom deliver to us? Well, in short, it removes the blinders over our eyes that prevent us from seeing both the big picture of how your data ecosystem functions, as well as at the lowest level of how that data is transformed throughout its lineage lifecycle. It delivers actionable intelligence around improvements, as well as stark warnings around adjustments. By having a window into the otherwise unknown, you as an analyst, architect, decision maker, or data consumer will be better equipped to make decisions that directly impact the information which is being used as the lifeblood for your business critical applications and trajectory shifting business reports. Decisions that, if not adequately researched, can cause data discrepancies downstream with unknown levels of effects on your production environment and on the information your executive boards are being provided for making projections and plans off of. Today, let me take you on a short journey around the data lineage world. We will make a few stops along the way at different companies where accurately mapped data flows were able to unwind the complexity of ETL tools and indirect data impacts to help guide teams to launch and debug DataOps projects, properly plan migrations, and apply data governance improvements. Before we take off to begin our excursion of the lineage landscape, let's take a look at how data flow would be represented in a lineage tool and talk a bit about how a company would interpret the diagrams when analyzing visualizations of their own metadata. This screenshot represents the data movements from 4 different technologies across multiple servers. What you'll notice when looking at this diagram is that we have multiple sets of boxes, which are connected to one another with an array of arrows. The boxes represent objects in the data flow. An object can be a database, a schema, ETL component, a report, as well as a wide variety of other data housing or manipulating nodes. On the right-hand side, we have a grouping of objects which are representing an SSRS report and are denoted by the black coloring convention. The outermost box is our customer report level objects, while the innermost boxes are our field level objects. The relationships these objects have with one another is represented by the arrows that connect them. The arrows denote the data movements from one place to the next. When combining everything together, we can visually track the physical flow of information throughout its entire Lineage lifecycle, all the way down to the column or field level movements. By clicking on a specific field, we can see the visualization respond by highlighting the data flows for your chosen object. We can see upstream data movements from our selected field, highlighted by the blue coloring convention, and the downstream movements highlighted by the red coloring. These coloring theme updates help the user to visually track all the movements throughout the data flow that relate to their selected element, so that they can pinpoint specific areas of interest with ease and understand which objects relate to one another. Having this level of granularity and control over your information can prove to be a tremendous benefit when working on projects such as data governance, which is an easy segue for me into my next slide. So as you may have already guessed, our first stop on today's voyage is the land of data governance. One of the leading struggles our clients face with regards to their data governance processes is a lack of data documentation. Where is the data coming from? Where is the data going to? How was the data transformed? Having an accurate, detailed account for the data lineage will help to answer all of these questions, while checking off the boxes we see here for meeting regulatory compliances and commitments faster, increasing the trust in your data and its uses, helping to define the scope for your governance plans while integrating with your governance tools. At the end of the day, the problems that stem from not having proper governance in place are much more daunting than the struggles to implement one. Facing compliance regulations or violations are more painful than choosing even the most manual method for collecting and updating data. But manual efforts can only take a company so far. There will still be vulnerabilities to errors from user entry, to missing or overlooked information, collaboration inefficiencies, and potential metadata loss. One of our accounts in particular had a need for a comprehensive Basel III solution to help with meeting new banking regulations and the need to reduce the level of manual metadata collection efforts. For this specific account, it was an experience they had with one of their own customers that started them down the data lineage path. As a global leader in the financial industry, the credit approval process is a key staple to their business. When individuals apply for loans, their applications go through the approval process and they receive an accepted or rejected status at the end of the workflow. This is a very standard operation for mitigating the risk involved in providing credit to would-be clients. But what happens when an individual applies for credit and gets rejected, only to reapply a few months later and get approved? When this situation started to be brought up to the company's attention as being a reoccurring trend for their credit applicants, an investigation was launched to identify the causes behind the new behaviors. It took a team of resources, months of combing through and comparing changes made to their internal approval processes between when applicants were applying and being rejected to when they were applying and being approved. At the end of the project, 2 main things were learned. The first was that there was a new algorithm which was deployed in the months prior to seeing the influx in credit approvals, which changed the way their internal system calculated credit loan applications. This was the answer they originally sought out to learn. The second lesson was that it was painstakingly difficult to process and track and compare changes to lineage flows for addressing inquiries around new or unexpected behaviors to their core applications. So the decision was made to bring in a data lineage tool into the organization for helping with these situations going forward. The result of deploying that solution was the automation of tedious processes of data flow discovery for the finance and risk departments. The account was able to expand the reporting to hundreds of KPIs rather than only a handful. and the project became integrated into the company's broader data governance initiatives. Today, this account is utilizing data lineage for a wide variety of use cases in compliance, impact analysis, and data ops alike. Speaking of data ops, this use case is the focus of our next account struggles and will be the next stop on our Lineage tour. For those of you who may be new to the data ops landscape, allow me to set the scene. Data ops simply combines agile development, DevOps, and statistical process controls, then applies them to data analytics in an automated process-oriented methodology. I think of it as being a bit like test-driven development applied to data analytics, where the tests are then applied to the production objects you're creating. Used by analysts and data teams alike to improve the quality of data that is provided to reports and applications while reducing the cycle time of data analysis. Data ops applies to the entire data lifecycle from data preparation to reporting. Introducing data lineage into this space adds a new paradigm to the process. By inserting a fully mapped data pipeline into the mix, organizations will now have the visibility into all systems throughout the ecosystem, breaking down the walls that once siloed teams from viewing data flows owned by other departments. Being able to access this information visually with just a few keystrokes or programmatically via an API dramatically reshapes the routines typically associated with researching and documenting data sources and movements before ever putting pen to paper to design a project. One of our accounts came to us with a highly sophisticated data environment, which was being taxed by the increases they were seeing come through for updates and modifications. The bottlenecks around minimal collaboration between groups within the organization, tedious data analysis requirements to avoid poor quality result sets, and an impact review board picking apart each project slowed their team down to a point where they could no longer keep up with the demand impressed upon them. Rolling out data lineage to this group meant that protocols for impact analysis and debugging could be handled in a fraction of the time compared to the previous processes. Change logs of each release's modifications to the ecosystem were created and stored for future referencing. And the time it took to implement a project into production was dramatically reduced. Today, the Lineage solution that started with a single group in the organization has now expanded to be an enterprise-wide initiative. In looking at this slide, we can see some of the high-level bullet points of the project. There's one listed here in particular that's worth discussing a bit further. That's a bullet point which states data pipeline fully mapped and understood via Lineage to speed up debugging. So what does that actually mean and how does that work? So imagine your team has spent the time to deploy a data ops platform for testing and monitoring your data quality. Your engineers are now building out and test cases for running on your dev environments before rolling changes out to prod. And you have a data monitoring tests to validate that the flow of information is always as expected. Months after beginning to build with a new platform, you receive an alert that something went wrong in production. A table has a validation step which checks to make sure that there is always more than 10,000 rows within it at a time. The notification provides a link to the specific asset that failed the validation. You know that that data flow doesn't end at this asset though. There are other downstream resources which are also being impacted. We have a bug. Something is preventing that data flow from ever getting to your table. The data ops platform has done its job by monitoring the system and alerting you of the issue. And now you and your team need to notify the owners of the impacted applications, as well as research the changes made to all upstream sources which feed into your data set. Doing this manually, as we saw with our previous case study with the financial institution, can take time. So having a diagram that outlines all the flows of data to your impacted asset is going to provide a tremendous advantage for resolving this bottleneck. Even better though, is having a lineage diagram that highlights the recent changes made to those objects that relate to your failed tests. This can guide your team directly to the components that need to investigate. They need to investigate for resolving the bugs in as little amount of time as possible. At the end of the day, there's never going to be an instruction pamphlet with clearly defined steps to walk you through these types of situations. But having the appropriate tools and procedures in place for addressing them when they occur will provide you with the information needed to write your own playbook for handling them. Continuing our data lineage journey around the data lineage universe, we're going to come to our third and final stop, cloud migrations. So after much internal deliberation, your company has not only decided to move their infrastructure to the cloud, but they have also chosen the new tech stack you'll be moving to as well. And unfortunately for the team, none of the new technologies can be mapped one-to-one with what's currently managed on-prem. This means that the expectations are not only just to move the data and corresponding flows to their new resting place in the metaphorical sky, whose airspace is most likely maintained by Amazon, Google, or Microsoft, but to also improve upon those current inefficiencies hidden deep within your soon-to-be antiquated system's darkest layers of metadata. So if the tasks are to move one database, you shouldn't have too many troubles. 2 databases, you still could have a bit to handle, but you can get on top of that. 10 databases, you might want to quickly check the timelines of the project, because this could be a bit of work. 100 databases, or worse, 1,000 databases, you might have a problem. If this information is business critical, which it usually is, and you have a tight timeline, which generally goes unsaid, you may want to consider looping in a tool to help. Having your data lineage documented for your teams to be able to work off of as they're building your new ecosystem in the cloud is really the only way you can confidently track the progress of your project with the comfort of knowing you haven't missed any components in the process. The other pieces to this puzzle is that you may have, as you're making the switch to this cloud environment, your on-prem ecosystem is still an active construction zone, with changes being pushed to it on a regular basis. These changes need to be accounted for and applied to the new environment, which means you'll need to complete collaboration between teams and departments. Even with this, there is a chance that code may slip through the cracks and unaccounted for variables get thrown into the mix. So unaccounted for variables could be things like mergers and acquisitions that happen while you're in the middle of an infrastructure project, because these things do happen. To help prevent this, to help improve all of this, having continuous lineage checks of your current state versus the previous state is not just a nice to have, but a requirement to ensure that everything is being reviewed and accounted for throughout the duration of the migration efforts. This slide helps to illustrate some of the advantages to utilizing a data lineage tool when working through a migration project. Everything from the scoping of the project to identifying redundancies and validating that nothing has been missed can all be aided with the guidance from Lineage. Looping in the automated capability to compare the different states of your on-prem environment over the course of the migration, and you'll have a blueprint for what needs to be done for your team to be able to complete everything successfully. In our next case study, we have an account that came to us for help with their migration from a large data warehouse platform to Snowflake. They were struggling with missing objects, broken dependencies, and prolonged development times, which were putting them behind schedule. The decision was made to implement a data lineage tool for helping to piece the project together. The original approach was to first migrate certain components from the data warehouse to the cloud in an attempt to take advantage of the new infrastructure as soon as possible and reduce the level of complexity associated with the move. Reports were rated based on their level of importance to the business, and plans were made for migrating the most important reports and their data flows to the cloud environment first. When data lineage was brought to the table, though, the reality of the situation set in. The pipelines that moved the data into the reports were shared across the board with no regard for the level of importance that each report had to the business. So to migrate only certain higher important elements to the cloud would mean they would either need to break the pipelines feeding into those less important reports, or they would need to synchronize the data flows so that both environments receive the same information. Both approaches had their downsides. So rather than choosing either one of these options, the decision was made to reprioritize the objects being migrated in a manner that didn't require pipelines to be broken or data to be replicated. This was only possible after the flows were mapped and the team was able to untangle the dependencies from one another with data lineage. Once completed, the project timelines were able to be predictably reset and the migration work was able to commence. The result of all of these efforts was a successful migration to the cloud for all their assets and the completion of the project on schedule. Today, data lineage still plays a part in the organization's data operations and future plans for other migration projects. So there's one thing that we haven't necessarily touched upon yet, and that's what makes data lineage difficult to achieve. Not every company is able to successfully deploy this type of initiative. So there are a number of challenges that come into play when attempting to implement a successful data lineage solution. From the scoping of the project, what resources do you include versus exclude for the different phases, to the use of bleeding edge technologies. If you've adopted the latest PySpark framework or other ETL tool out there on the market, you're going to have some struggles with finding a lineage tool to support them. There are always going to be some hiccups along the way. Even if you control all these factors and press restrictions onto your team around what tools and technologies they can and cannot use, there are still a number of variables you won't be able to control, such as mergers and acquisitions, like we mentioned earlier, human resources turnover, and unrealistic expectations of end users that will all come into play. I personally have worked with contacts for months on Lineage projects, getting their systems up to speed, as well as them trained on best practices for managing it, only to have them shuffled around the organization and placed onto other projects, then needing to restart the education process with new contacts so that they're able to successfully manage the solution. Committing to the adoption of Lineage and embedding it into your own routines and the routines of others is the key piece to the puzzle. At the root of all successful implementations is the same thing, going into the project with the right mindset. There are no silver bullets on the market that will handle every subtlety to your data universe, but the odds are you will also never need to have every subtlety at your fingertips. For example, harping on perfectly encapsulating the data type modifications made between two ETL stages may be a requirement for your engineers to be aware of as they code out new workflows. But that information most likely will never be utilized in the context of data lineage, as those same engineers build the workflows in the ETL tools themselves, where those aspects of the metadata are configured. The consumers of the data lineage will more likely just want to understand what stages relate to their resources of interest. So spending time on the aspects which are most important to you and to the consumers of the lineage is going to be far more fruitful than getting caught in the weeds of the metadata that is irrelevant to the movements underneath. Having the right mindset and perspective to what's important and what's less important will open doors to solutions that you may not have thought possible. This is a sophisticated space to be playing in, but with the right people helping you and the best tools working for you, it can provide endless dividends from efficiency improvements and data discrepancy avoidance. So with that said, what I'd like to do is just say thank you all for your time, and I'm going to open this up for some questions and answers. If you have anything that you would like to see further, definitely feel free to reach out to us here at Manta. We are happy to show you any type of lineage demonstrations that you may like to see, or we are also open to just having more just technical discussions with you.
Thank you, Joe. I do have a couple of questions here, and we do have some time for those. And my first question is, how does data lineage help with tracking changes being made to an environment?
Sure. So I can speak to the Manta product and how we approach this. So with Manta, a lineage, what we call as a lineage scan, is Manta will go out to all your different configured resources and extract the appropriate metadata, run an analysis on that metadata and commit it to a repository in the back end. This whole process creates what's called a revision. That revision can be thought of as a snapshot in time for your data lineage ecosystem. So if you schedule these revisions to be run on a regular cadence, let's say if you're launching a project and you have a 2-week sprint, so every 2 weeks you know you're going to push new code, you schedule a revision to be executed after every one of your sprints are completed. Now you have a historical revision repository set where you can go back to at any point in time and see how your environment looked at the time of the scan. We also have the ability to pull multiple revisions up in parallel, overlay them with one another, and then show the differences between the two. So if there's any type of new assets or deleted assets, it will be presented to the user inside the visualization with some type of coloring theme to bring your attention to it. So it'll help the users with identifying what's changed and how it's changed.
Perfect, thank you. And another question here is, how can a data lineage help with impact analysis?
Sure, absolutely. So if you have database tables, elements at the root of your lineage, there's most likely a large number of resources that are pulling from those specific assets. a lineage tool, a proper lineage tool, will be able to show you all the different objects that relate to that specific element, either by clicking on it within the visualization and then following the lineage flow downstream, or programmatically by pinging it with an API. Here at Manta, we have both. You can ping the API and say, give me all the specific asset information that relate to this element that I've chosen, or you can go in the user interface and then choose it. Give me this table, and I want to see all objects downstream which are sourcing from it. So the lineage tool can help you in both manners to get to the root cause or the potential impact analysis if you were to modify any one of these elements.
Perfect. And I have two more here, Joe, which is the next one is, how would you represent custom written applications in a lineage diagram?
So this is probably one of the most challenging questions you could really be brought up. There's always going to be custom applications out there. There's always going to be technologies that you don't have a scanner source, any type of technology to be able to support, and you need to represent those lineage flows. So with Manta, we have a technique, we have a few different techniques actually, where you can create these objects within your repository, either in a programmatic type of way through the actual code generation. So actually reading the code that's written to the application via either annotations or the code itself, if it's written in the supported language, as well as just saying, okay, I want to generate this object. And I can do that with Manta with just a simple CSV file. I can create a CSV file, tell the system what I want this object to be and how I want it to be represented, and then how it relates to all the other objects within my lineage flow. I'm going to connect all these different dots. So for the elements that are unsupported, having multiple techniques to approach them, whether it be from physically writing CSV code or programmatically adjusting the annotations that you provide in the actual application code itself, you want to get that into the actual tool for visualization. And the Manta application opens that up for you so you can do so.
Perfect. And the last question I have as of right now is how are logical operators handled in a lineage tool?
Yep. So logical operators can be a little bit challenging. For both the lineage tool itself as well as the viewer who's reading the lineage. What you'll have is you'll see situations where data flows will be indirectly impacted based on the logic that's written in the code. It could be a case statement, it could be a where clause, or any one of the logical operators that say, I'm going to funnel the information that's moving downstream based on some logic that the programmer has designed. This can be visually shown inside a lineage tool. And in fact, the Manta application does have the way to visualize this, but you also want to see it a little bit differently than the rest of the data flow. So it's a direct data flow, one option, and then having a conditional lineage operator on top of it gives you an indirect data flow. You want to have these represented in two different ways, which the Manta tool is able to do. So essentially what you want to do is read the logic and then present to the user all the potential options that could come out of that logic, regardless of anything underneath it. I want to see if it's written in the code and could potentially happen. I want to see that data flow. I want to see that acknowledged. So with Manta, it's able to do so, and it does so with a different type of relationship line connecting the objects. So you can see, oh, this is a indirect lineage flow rather than what I would traditionally see, which is my direct lineage line. Let me investigate the actual underlying code to see how those logical operators are written and understand where that information is coming from and what filters or clauses are being applied to it that would limit all the data from flowing through it to downstream elements.
Perfect. Thank you, Joe. That's all the questions that I have. Is there anything else that you would like to add?
Nope, I think that's it for me. If anybody has any questions, definitely feel free to reach out to us directly, and we'll be happy to take your call and go through things in more detail with you.
Perfect. Thank you so much, Joe.